Hello everyone. So when I found out that I would be the first speaker today, my first thought was, how am I going to break the ice? Well, it turns out that pollution may be just doing just that. So how we created our new mission is we took IceBridge and Discover AQ and we analyzed their scientific objectives and looked for the similarities. And from that, we were able to create a completely new mission, Disguise AQ. So Discover AQ, just a little background, Discover AQ is focused on measuring the pollutants in the air over urban cities. And IceBridge is measuring the thickness of the ice in Greenland and Antarctica. So, once we had our mission goal, which is to characterize the changes in the mass and thickness of ice sheets and glaciers, and to characterize the difference in air quality in areas where the ice is gaining and losing mass, and to determine whether that is due to pollutants in the air. We started to narrow that down into specific mission objectives. We got 3 mission objectives. The first one is to understand the pollution in the air and what may or may not be changing that, and then to quantify the changes in the thickness in the ice, and to understand how they may be related. Thank you. I'll turn this over to my science officers.
Hello, my name is George Denny. I'm from Bristol, VA. I am a science officer on Disguise AQ. First off, I'd like to point out that where we got our science objectives and goals for this mission are not just simply out of the air. We actually went straight to the NASA goal, and then strategic goals and all the way down. So I'm going to read out the NASA main goal so you can see how we correlate. NASA's goal is to drive advances in science, technology, and exploration to enhance knowledge, education, innovation, economic vitality, and stewardship of the Earth. So now that you know where our science was based out of, I will go ahead and proceed with our experiment. For our experiment, we will be testing both polar biomes, that being the Arctic Circle and the Antarctic continent. There will be 8 pre-decided locations where we will be testing the air quality in air columns above specific points. These points will have 3 areas where ice has been known to be melting or losing thickness, 3 areas where the ice is reforming or gaining thickness, and 2 areas where there is a net zero gain or loss in ice, so that we have control as we see how many pollutants in the air there is. The pollutants that we are trying to monitor are CO2, carbon monoxide, methane, nitrogen dinitrogen monoxide, and water vapor. The reason why we have these science goals to do this mission is mainly because of the relevance to social and societal needs within this scientific community. Climate change. Climate change is causing a huge rift in the various arguments over the data. Right now, there is a lot of speculation with a lot of logic, but there is no hardcore data over the air quality of melting points in the polar regions as compared to points of not melting or forming. So we want to give a solid basis and to help our understanding. NASA has always been a big front runner in providing social needs and huge scientific improvements. So, by running Disguise AQ, NASA will be leading once again in social needs and helping to put the facts back into the argument. Okay, and here is my science compatriot.
Hello, everyone. My name is Luke Rolensick, and I'm from Fairfax, Virginia, and I'm also part of the science. I'm also a science officer for the Disguise AQ mission. Adding on to the reason why we're doing the studies we're doing is because it involves the wildlife in the polar regions. In a recent study by Casey Sewell, about 2/3 of the polar bears in the world will be gone by 2050. Unsurprisingly, it's because of the loss of sea ice. So observing and analyzing the data obtained in this mission could help show high potential in solutions to the problem we're seeing now. But time can play a bigger important role in our mission. The data and information we get can directly affect the lives of polar bears now and in the future. Though the subject is very controversial, our data that we're going to be obtaining is not. Our missions obtain information about possible correlation of pollutants directly related to loss of ice. Will help separate speculations with the facts. Debate over global climate change is very controversial and will be controversial in the future. The data to support or dispute the immediate amounts of pollution in areas that are socially inhabited are affecting the polar regions is meant to be relayed and not swayed.
Is that what I said? Oh, this time. So now that we know what our science objectives are, the next stage is to start looking at how we're going to complete this, how we're going to gather the data we need. So what we did is we created a list of specifications for both our platforms and payloads. So for our payloads, we needed to go over, we needed to find a way to measure the air quality and the pollutants in the atmosphere. And then we also needed to know how to map the terrain and measure the depth of the ice. For the platforms, we had several components that we needed to consider. The high and low altitudes, long duration and time durations for our aircraft. It needed to be highly maneuverable and have multiple cruising speeds so that we could get to our location quickly, but then go slow enough so that we could take the data we need. And also, we need a large carrying capacity so that we could carry the combined sensors of Discover AQ and Ice Bridges payloads.
Well, my name is Jacob Rickman. I'm from Chautauqua, Virginia. I'm the engineer officer. What I wanted to talk about was the payload and the payload and platform and the flight plans. There were many difficulties in doing the platform. Like my colleague said, we needed good maneuverability, high and low altitudes, and carrying capacity. But there were three options in the platform that we needed to choose from. was the DC-8, the P-3B, the P-3C Orion. What the platform that we chose was a P-3C Orion because of that. Anyway, let's talk about our flight plans. First off, we're going to Antarctica, and these are the flight plans for the past couple of years of Icebridge. What we wanted to do is start from Walt's flight facility, travel to Punta Arenas, Chile. From there, refuel, take a couple days, and then head to probably about right there to a site of predicted ice loss to study, and then do a descending column from 30,000 feet to about 7,000 feet. Then we wanted to cruise about 7,000 feet and travel all the way down to about right there, and then do a ascending column from 7,000 feet to 30,000 feet to study the layers of air to see if the pollution is true to be. But what we do understand is that Antarctica is a control to this experiment, because we have two more plans. First off, we could go to Greenland. We would travel from Alaska, Fairbanks, all the way over and go from airport to airport to airport, doing vertical columns. We would spend the day there and fly back to Fairbanks. We also wanted to do is study Alaska. You may not seem important, but it is, because there is some ice caps of permafrost and the stuff like that. So what we wanted to do is travel from Fairbanks and do this whole east coast of vertical columns, then probably refuel at Barlow if we could, and then fly back to Fairbanks. Anyway, this is the next.
I'm Seva Somayajula. I am the mission technologist that specializes in Discover AQ side of sensors and instrumentation, and I'm from Herndon, Virginia. So, Discover AQ specializes in air quality metrics and atmospheric composition. Thus, most of its sensors are spectrometers, which are special types of sensors which have inlets, which input any gases or chemicals, runs tests on them and identifies them, and in some cases even collects data about them. So our first sensor is LARGE, which is the Langley Aerosol Research Group Experiment. It's a cluster of instrumentation which is housed on board inside the cabin of P-3C Orion, which collects aerosol metrics, character, composition, etc. And like all P-3C Orions and any other airborne laboratories, there is a stock data system on board which provides basic navigational and geological data, such as altitude and location. There is also a DACOM, which is a differential absorption of CO measurements, and it is a 3-channel tunable diode laser spectrometer which identifies carbon dioxide, methane, and dinitrogen monoxide. There is also an advocate which complements the DACOM, and it is completely focused on carbon dioxide. It is called an atmospheric vertical observations of carbon dioxide in the Earth's troposphere, and it is a carbon dioxide identifier and a levels tracer. There is also a ACAM, which is an airborne compact atmospheric map. It consists of 2 spectrographs and a high-definition video camera, and it maps the atmosphere, much like remote sensing. And last but not least, there is a DLH, or a diode laser hygrometer, which it is a spectrometer which identifies water. And my colleague will cover the Icebridge side of things.
Hello, my name is Matthew Kramer, and I'm another mission technologist, and I'm from McLean, Virginia. The first instrument that we'll be using for the Icebridge side of measuring the terrain is the Atlas Laser Altimeter, and this measures the changes in the ice elevation. And this is a new laser technology that's being developed for ICESat-2, which launches in 2017. It uses a system of 3 lasers to detect the elevation of the ice. And this has a very low, it has a low technology readiness level, and so we need to set aside more budget for this and maybe some time to help develop it to use for this mission. The second set of sensors that we'll be using are snow radar, MCO RDS, and some other radar systems. And the snow radar measures the thickness of the snow, and the MCO RDS measures the bedrock under the ice. And these sensors, we couldn't find any research data on the maximum operating altitude for the radars. And so since we're flying at a higher altitude than the current ice bridge missions, we would need to do some testing to see if these radars will work at the altitude we're trying to use them at. And then the last set, which aren't on the slide, are the gravimeter and the magnetometer, which will measure the snow and ice that's under the ocean.
Hello, my name is Christine Odenwald and I'm from Chesapeake, Virginia. As one of the communication officers for this mission, my goal was to create an outreach plan that was simple, effective, creative, and appeals to many people. And it was also easy to access. The first thing that we will have is a mission Facebook page. If a viewer likes this page, he or she will receive updates weekly on the mission and have access to photos pertaining to the mission and data collected. Also, we will have a Twitter account. If someone follows us on Twitter, he or she will receive short, concise updates on the mission of no more than 140 characters each. Now, if you know Twitter, you're not allowed to type more than that. However, he or she will have the opportunity to participate in TwitCams, where he or she will have the chance to ask questions directly to the NASA scientists who are directly involved in this mission. This meets the main goal of a communication officer, which is to link the people directly to the NASA mission, as viewers are allowed to directly interact with the NASA specialists. Another thing that we will have in our outreach plan is a scientific journal. This journal will be written by the NASA scientists that are working on this mission. This will be a personal account to a scientist's specific role in the program and the data that he or she has collected. And now to Vanessa.
Hello everyone, my name is Vanessa Moses. I'm from Keller, Virginia, Eastern Shore, and I'm also a communications officer. So I'm pretty sure that everyone here is familiar with Google Earth. So for the Disc Ice AQ mission, we'll be taking the same concept of Google Earth, but expanding it a little bit farther. The name of this website will be Discover Pollution, and it's open to anyone in the world with internet access. Discover Pollution will offer you views of areas including Greenland, Antarctica, and Alaska. These pictures will change with the seasons. So like, for instance, here you see a lot of ice, but this is only August in Greenland. So if you were to change the season to December or October, there will be ice all the way down here. And also, you'll be able to zoom in into the picture, and you would see a 3D panorama of a diagram showing air pollution concentrations. So red will mean a whole lot of pollution, or a strong concentration of pollution. Yellow will be moderate, and green will be, nah, it's not that much. And the Discover Pollution site will help connect curious minds to the NASA mission that will take place in isolated places. So this is the conclusion of our PowerPoint. And I'd like to thank everyone who came here today, and that's pretty much it.
Okay, so so we're going to take questions, or they're going to take questions in the audience.
Testing? Alright. Wasn't sure if it was on. So, simple answer, a lot. This group was very unique in that we all had to work really hard to get here, and there was a filtering out process. So this quite easily is the smartest people I have ever worked with. And they were relatively easy to manage because of that. They were really on the ball. I think we would agree that as a group, we worked pretty well together. We communicated well, and we didn't seem to have too many problems, and when we did, we were able to find solutions relatively quickly.
Could you tell me why American taxpayers should pay for this particular mission? What, you know, if I'm a resident of Hampton, why would I care?
I think the simplest answer would be that every space scholar here is going to be a scientist or an engineer or someone in communications. All of us will have big influences on the future. The best way to ensure that you will have a prosperous future is to work on the youth. With this opportunity, we have been able to visit around Walt's flight facility and learn more about the various things that go on in NASA. To an extent, there is a lot of unknowns that stress each and every one of us out. I know personally I had a lot of issues thinking, well, maybe I'm just not smart enough, or I won't be quick enough on the uptake to get into NASA. But the more that we've talked, the more we can see how tangible it is. By being here at this program, you're investing to have future scientists who already have worked together, have an understanding of our common similarities, and are willing to go above and beyond to ensure that we will finish the mission and do the objectives.
I'd also like to add, who really doesn't want to save the polar bears? They're pretty cute.
So what kind of time scale do you think this mission would be on? Like how long before the first actual solar would launch? Approximately.
So there's several factors that come into this. The main one is that as there was an ISAT-1, which basically was the predecessor to IceBridge, and then ISAT-2 will be taking over IceBridge. So what we want to do is, to the best of our ability, complement those missions. So I believe ISAT-2 comes in at 2017. So I would say sometime around then, because they are a little bit different but similar. The other thing is that I'm not a tech guy, but we have certain sensors that are in the stages of being developed, and we still have testing to do. So there's limitations on what we can do right now until we actually develop the technology.
Thank you.
I have a question. Did you look at a platform at all of using a satellite instead of an airplane to do some of these testing?
We didn't really consider that much because The part from Discover AQ was the air quality testing, and for the sensors to work, they need to take the sample. They need to intake air samples directly from the altitude that we want to gather them at. So if we want to learn about like directly above the ice caps, we can't have a satellite because that can just take in the little tiny bit of air that there is in space, and it won't give us the info we want. But the carbon dioxide and the other things we're testing for will be at the altitude that we're testing at.
Thank you. I have a follow-up question. Earlier Joyce asked a question, and I wanted to know your answer a little bit differently. Why should the public care about investing in Discover Ice AQ? Not Space Coast, but this mission.
I think we should invest in this program that we have all came to conclusion about, because if we lose all of the polar ice caps, that will raise sea level. I'm not saying it's global warming, I'm saying it's climate change. Because if that ice does melt, like I talked to Mr. Youngel, which was an ice free program, he told me Greenland was losing ice at a fast rate. They were sea level around Greenland